Good evening. Today I am here to present webinar on the topic 5G future and role of satellites. Today we are on the verge of seeing what a truly connected world looks like. It's projected that soon there will be 6 billion people online, 30 billion devices and 50 billion machines online. That's essentially everyone and everything connected across every geography, supporting every application from consumer broadband, mobile gaming, and connected cars to global business networks, ships, planes, soldiers, first responders, and connected firms. Supporting a connected world is a daunting challenge that today's telecom infrastructure is simply not equipped to handle. In this webinar, we'll provide you with an overview of the key 5G technology innovations, the new application and use cases 5G will address, and our view of the 5G opportunity for satellite. First of all, what is 5G and what does it offer? 5G is a fifth generation mobile network. It is a new global wireless standard after 1G, 2G, 3G, and 4G network. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. Next, what does it offer? 5G wireless technology is meant to deliver higher multi-gigabits per second, peak data speeds, ultra-low latency, more reliability, massive network capacity, increased availability, and a more uniform user experience to more users. Higher performance and improved efficiency empower new user experiences and connect new industries. Next, who invented 5G? No one company or person owns 5G, but there are several companies within the mobile ecosystem that are contributing to bringing 5G to life. Qualcomm has played a major role in inventing many foundational technologies that drive the industry forward and make up 5G the next wireless standard. Third generation partnership project 3GPP, the industry organization that defines global specification for 3G UMTS, 4G LTE, and 5G technologies. 3GPP is driving many essential inventions across all aspects of 5G design, from the air interface to the service layer. Other 3GPP 5G members range from infrastructure vendors and component or device manufacturers to mobile network operators and vertical service providers. Next, what underlying technology make up 5G? 5G is based on OFD, orthogonal frequency division multiplexing, a method for modulating a digital signal across several different channels to reduce interference. 5G uses 5G NR air interface alongside OFDM principles. 5G also uses wider bandwidth technology such as sub-6 GHz and millimeter wave. Like 4G LTE, 5G OFDM operates based on the same mobile networking principles. However, the new 5G NR air interface can further enhance OFDM to deliver a much higher degree of flexibility and scalability. This could provide more 5G access to more people and things for a variety of different use cases. 5G will bring wider bandwidths by expanding the usage of spectrum resources from sub 3 GHz used in 4G to 100 GHz and beyond. 5G can operate in both lower bands as well as in mmWave, which will bring extreme capacity, multi-gigabits per second throughput, and low latency. Next, what are the difference between 5G, and previous generations of mobile network. The previous generations of mobile network are 1G, 2G, 3G, and 4G. First generation 1G. In 1980s, 1G delivered analog voice. Second generation 2G in early 1990s, 2G introduced digital voice, and third generation 3G in early 2000, 3G brought mobile data, and fourth generation 4G LTE in 2010, 4G LTE ushered in the era of mobile broadband. 1G, 2G, 3G, and 4G all led to 5G, which is designed to provide more connectivity than was ever available before. 5G is unified and more capable air interface. It has been designed with an extended capacity to enable next generation user experiences, empower new deployment models, and deliver new services. With high speeds, superior reliability, and negligible latency, 5G will expand mobile ecosystem into new realms. 5G will impact every industry, making safer transportation, remote healthcare, precision agriculture, and digitized logistics. How is 5G better than 4G? 5G is significantly faster than 4G, delivering up to 20 gigabits per second peak data rates and 100 plus megabits per second average data rates. 5G has more capacity than 4G. 5G is designed to support a 100 times increase in traffic capacity and a network efficiency. 5G has a significantly lower latency than 4G. 5G has significantly lower latency to deliver more instantaneous real-time access, a 10 times decrease in end-to-end latency down to 1 millisecond. Next one, 5G is a unified platform that is more capable than 4G. While 4G LTE is focused on delivering much faster mobile broadband services than 3G, 5G is designed to be a unified, more capable platform that only elevates mobile broadband experiences but also supports new services such as mission critical communication and the massive IoT. 5G can also natively support all spectrum types and bands, a wide range of deployment models, and new ways to interconnect. 5G uses a spectrum better than 4G. 5G is also designed to get most out of every bit of spectrum across a wide array of available spectrum regulatory paradigms and bands, from lower bands below 1 GHz to mid bands from 1 GHz to 6 GHz to high bands known as millimeter wave. Next, how and when will 5G affect the global economy? 5G is driving global growth. $13.2 trillion of economic output, 22.3 million new jobs are created, $2.1 trillion in GDP growth. Through a landmark 5G economic study, we found that 5G's full economic effect will likely be realized across the globe by 2035, supporting a wide range of industries and potentially enabling up to 13.2 trillion worth of goods and services. This impact is much greater than previous network generation. The development requirements of the new 5G networks are also expanding beyond the traditional mobile networking players to industries such as the automotive industry. Studies also revealed that the 5G value chain, including OEMs, operators, content creators, app developers, and consumers, could alone support up to 22.3 million jobs, or more than one job for every person in Beijing, China. And there are many emerging and new applications that will still be defined in the future. Only time will tell what the full 5G effect on the economy is going to be. Next, How will 5G affect me? 5G is designed to do a variety of things that can transform our lives, including giving us faster download speeds, low latency, and more capacity and connectivity for billions of devices, especially in the areas of virtual reality, the IoT, and artificial intelligence. For example, with 5G, you can access new and improved experiences, including near instant access to cloud services, multiplayer cloud gaming, and shopping with augmented reality and real time video translation and collaboration and more. 5G is foundational to what's next, a unified connectivity fabric for everything. Broadly speaking, 5G is used across three main types of connected services, including enhanced mobile broadband, mission critical communications, and massive IoT. A defining capability of 5G is that it is designed for forward compatibility, the ability to flexibly support future services that are unknown today. First one, enhanced mobile broadband. In addition to making our smartphones better, 5G mobile technology can usher in new immersive experience such as VR and AR with faster, more uniform data rates, lower latency, and lower cost per bit. Next, mission critical communication. 5G can enable new services that can transform industries with ultra reliable, available, low latency link like remote control of critical infrastructure, vehicles, and medical procedures. Next one, massive IoT. 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything through the ability to scale down in data rates, power, and mobility, providing extremely lean and low cost connectivity solutions. Fuels a new era of innovation, and 5G will enrich many lives by turning the ordinary into extraordinary. How do consumers use 5G? The average consumer is expected to go from being able to consume 2.3 GB of data per month today to close to 11 GB of data per month on that smartphone in 2022. This is driven by explosive growth in video traffic as mobile is increasingly becoming the source of media and entertainment, as well as the massive growth in always connected cloud computing and experiences. 4G completely changed how we consume information. In the past decade, we have finished leaps and bounds in the mobile app industry around services such as video streaming, ride sharing, food delivery, and more. 5G will expand mobile ecosystem to new industries. This will contribute to cutting-edge user experience such as boundless extreme reality, seamless IoT capabilities, new enterprise application, low interactive content, and instant cloud access, to name a few. How do business use 5G? The benefits of 5G will enhance the efficiency of business while also giving users faster access to information. With high data speeds and superior network reliability, 5G will have a tremendous impact on business. Depending on the industry, some business can make full use of 5G capabilities, especially those needing the high speed, low latency, and network capacity that 5G is designed to provide. For example, smart factories could use 5G to run industrial Ethernet to help them increase operational productivity and precision. How do cities use 5G? Smart cities could use 5G in a variety of ways to transform the lives of people living in them, primarily providing greater efficiencies like more connectivity between people and things, higher data speeds, and lower latency than ever before in areas like automotive safety, infrastructure, VR, and entertainment. How fast is 5G? 5G is designed to deliver peak data rates up to 20 gigabits per second based on IMT 2020 requirements. Qualcomm Technologies' flagship 5G solution, the Qualcomm Snapdragon X55 and Snapdragon X60 modern RF systems, are designed to achieve up to 7.5 gigabits per second in downlink peak data rates. But 5G is about more than just how fast it is. In addition to higher peak data rates, 5G is designed to provide much more network capacity by expanding into new spectrum such as mmWave. 5G can also deliver much lower latency for a more immediate response and can provide an overall more uniform user experience so that the data rate may consistently high even when users are moving around. And the new 5G NR mobile network is backed up by Gigabit LTE coverage foundation, which can provide a ubiquitous gigabit class connectivity. How does 5G work? 5G network uses a system of cell sites that divide the territory into sectors and send encoded data through radio waves. Each cell is connected to a network backbone, whether through a wired or a wireless backhaul connection. 5G network use a type of encoding called OFDM, orthogonal frequency division multiplexer, which is similar to the encoding that 4G LTE uses. Their interface is designed for a much lower latency and greater flexibility than LTE though. With the same airwaves as 4G, the 5G radio system can get about 30% better speed, and it's because of more efficient encoding. While most 4G channels are 20 MHz bonded together into up to 160 MHz at a time, 5G channels can be up to 100 MHz, with Verizon using as much as 800 MHz at a time. That's a much broader highway, but it also requires larger, clear blocks of airwaves than were available for 4G. That's where the higher, short distance millimeter wave frequencies come in. While the lower frequencies are occupied by 4G, by TV stations, by satellite firms, or by the military, there had been a huge amount of essentially unused higher frequencies available in the US, so carriers could easily construct wide routes or high speeds. 5G networks need to be much smarter than previous systems as they are juggling many more smaller cells that can change size and shape. But even with existing macro cells, Qualcomm says 5G will be able to boost capacity by 4 times over current systems by leveraging wider bandwidths and advanced antenna technologies. The goal is to have a far higher speeds available and far higher capacity per sector at far lower latency than 4G. The standard bodies involved are aiming at 20 gigabits per second speed and 1 millisecond latency, at which point very interesting things are began to happen. Does 5G change my home internet service? Yes, 5G can change home internet service by providing a wireless modem alternative to existing wires. Internet service provider can now serve customers using 5G infrastructure, making the coverage, performance, and deployment flexibility of 5G a compelling backhaul alternative to fiber, DSL, or cabled solution. Now, role of satellite in 5G. Satellite communication will be an essential part of 5G. The satellite transport conduit will integrate into overall available communication map. The service provider will need to provide seamless connectivity between the terrestrial and the satellite. Traffic will be dynamically steered to the best transport options available according to the bandwidth, latency, network conditions, and other application-specific requirements. A suite of orchestrators will make the steering decision. This internetworking between terrestrial and the satellite is now recognized and promoted in 3GPP standards. For example, it's shown that the full integration within the virtualized architecture will apply to satellite as well, beginning with the network core and then expanding to the edge. The management of the NFV infrastructure will be performed through a management and orchestration framework. This architecture shows that it allows easy integration of multiple applications. A virtual evolved packet core application could extend local call switching possibilities. A mobile edge computing platform could host different applications like caching and multicasting, which can help reduce latency and improve quality of experience for the users. It is more than just standards. For mobile operators, 5G is far more than a faster version of 4G LTE or standard. 5G will be an entirely a new networking architecture, a network of networks with multiple access technology such as Wi-Fi, a small cells and traditional mobile network as well as terrestrial and satellite. It is being designed by the wireless industry to virtualize, automate and streamline service delivery. It brings technology together from three main areas. First one, evolved packet core from 3GPP and the cellular industry. Second one, network function virtualization and software defined network from the networking industry. Third one, virtualization and cloud computing technologies. It prompts network-wide innovations across telco, mobile and satellite networks. It is expected to transform how the communication industry at large operates and how users experience new connectivity services. Some of these new user experience will require ultra high speeds, some will require quasi real-time connections, and some will require massive scale for big data connecting millions of endpoints. Now, key 5G innovations. To successfully build all the connected 5G future, the communication industry must achieve a few key technological innovations. These innovations revolve around using EPC, orchestration, and a new waveform called 5G New Radio, 5GNR. This innovation is to dramatically increase speed, decrease latency, and allow for complete network orchestration. The use of SDN functionality and RAN's operation using the waveform NR in higher frequency bands is for faster speeds. The greater speed will also come from the use of higher frequency bands. Unlike 3G and 4G networks, 5G networks will run over higher frequencies such as 3 to 6 GHz, which overlaps with C-band satellite, and 26 to 30 GHz, which overlaps with Ka band, often referred to as millimeter wave within the wireless industry. The SDN functionality and NFV network works in unison to split up ECP functions within the cellular network. They will split traffic into control plane and data plane, thus separating decision making from traffic handling. Virtualizing and slicing the function within the network will allow dynamic orchestration of network resources. Thus, SDN functionality enables more efficient use of network resources to achieve higher speed connection. Ultra high frequency transmission across short distances. To reduce latency somewhat, the more important reduction in latency will come from efficiency that result from core 3GPP data and control plane function being pushed to the edge of the network. Stems from allowing multi-radio waveform under one standard. 5G application and its crucial role. The advanced communications of 5G are expected to transform three major use cases. First one, enhanced mobile broadband. Second one, ultra reliable and low latency communication. Third one, massive machine type communication. Enhanced mobile broadband. With 5G comes the opportunity to offer vastly enhanced and faster broadband connectivity to wide area networks, hotspots for mobile or fixed network. 5G to premises. 5G will complement terrestrial networks such as broadband connectivity to a home or office in an underserved area or to enterprise sites as a backup. 5G fixed backhaul. Satellite will bring broadband connectivity where it is difficult to deploy terrestrial connections in rural and remote areas across a wide geographic region only or best covered by a satellite. 5G mobility backhaul. Satellite will bring broadband connectivity to remote or UVs on the move such as airplanes, trains, vehicles or maritime vessels. Second one, ultra reliable and low latency communication. The second set of 5G use cases are ultra reliable and low latency communications that are particularly important for mission critical and pseudo real time applications. For example, let's consider as given in the figure the case of autonomous cars where latency is absolutely critical. To operate successfully, autonomous car needs to be able to talk to each other and their surroundings, also referred to as vehicle to everything, within milliseconds. Until the introduction of 5G, there had been no network capable of handling the sheer scale and low latency required to make autonomous driving a reality. The 5G standard is about to change that with lightning speed connections and smart routing. For example, in this use case, V2X data is distributed the fastest if it doesn't have to be routed to the core network and then back out to the base station. Rather, connectivity is established at the edge such that same base station is used to connect worker and the local sensors. Third one, massive machine type communication. This is used for M2M or IoT devices and sensors. SDN functionality will a crucial role here as it allows for a given UV to be serviced with a far fewer resources in return, enabling several UVs to be serviced with the equivalent resource of a single 4G UV. The 5G architecture needs to be dramatically scaled as it will be connecting and backhauling data from millions of smart devices and sensors inside homes and the urban infrastructure as they will become prevalent in smart cities of the future. While small in nature, the sheer aggregated volume of this M2M and IoT connectivity will have a major impact on the network load. In order to offload 5G network, one opportunity for satellite can be backhauling non-latency sensitive data from these devices or more precisely from the aggregation points back to the core network. Next one, key satellite challenges. First one, integration challenge. To enable satellites to extend coverage of cellular system in such a way as to improve quality and range of services, cost effectiveness, and energy utilization while reducing terminal costs. UOE challenge. Provide a guaranteed user experience across dimensions such as throughput, latency, and cost per bit independently of the user's location. Latency challenge. Match the latency demands of new interactive and immersive services below 100 milliseconds. Next one, spectrum challenge. To enable sharing of spectrum between the satellite and terrestrial millimeter bands above. Next one, Energy Reduction Challenge. The target is a reduction by 90% of today's energy at no reduction in performance and increase in cost. Next one, localization challenge. Provide in conjunction with terrestrial networks, positioning capabilities down to the millimeter range to enable diode. Next one, resilience challenge. To provide an overall integrated 5G system that is intrinsically robust to attacks of both man-made and natural causes that is trusted by strategic authorities. Next one, multi-service challenge that provide an overall network infrastructure that will efficiently accommodate M2M rate services as well as high rate video services and all those in between. Is 5G available now? Yes, 5G is already here today, and global operators started launching new 5G network in early 2019. Also, all major Android phone manufacturers are commercializing 5G phones, and soon, when more people may be able to access 5G, 5G has been deployed in 20 plus countries and counting. We are seeing much faster rollout and adoption compared to 4G. Consumers are very excited about the high speeds and low latencies. But 5G goes beyond these benefits by also providing the capability for mission critical services, enhanced mobile broadband, and massive IoT. When will 5G be available to more people? As with previous generations of mobile networks, it will take time to proliferate the new 5G network to make it available to more people. In the meantime, 4G LTE will continue to grow and serve as the anchor of the 5G mobile experience while multi-connected for many years to come by providing gigabit data rates outside 5G coverage areas. Next one, do I need a new phone if I want 5G? Yes, you will need to get a new smartphone that supports 5G if you want to be available to use the network. For example, smartphones powered by Snapdragon X55 or Snapdragon X60 modem RF system are 5G compatible. There are several new mobile phones available that are designed to support 5G and multiple carriers across the world that support the 5G wireless network. As the 5G rollout timeline progresses, more smartphones and carrier subscriptions will become available. As 5G technology and 5G compatible devices become more mainstream. Thus, we can conclude that as such, 5G will dramatically change how satellite is integrated into mainstream, achieving full interoperability within the end-to-end 5G network. In the past, the satellite industry has played a catch-up, spending extra time on the back end to find ways to integrate satellite technology into the prevalent standards and technologies. With 5G, the satellite network will be developed from the get-go to interoperate within a 5G architecture. 5G provides the ultimate opportunity for the satellite industry to break out of its niche and for satellite service provider to offer a much wider range of services while enabling mobile and fiber operators to leverage satellite connectivity to expand their coverage areas and offload their networks through critical functionalities like multicasting, backhauling, and mobility access, where satellite is a better access to technology. Finally, I thank IEEE PS Kerala chapter and Women in Power for giving me this opportunity to take this webinar. Thank you.
Thank you, Irene. On behalf of IEEE Kerala chapter, I would like to thank Ms. Irene Ann Zachariah for her informative and interesting session. Thank you, Irene. Also, I would like to thank all the participants for showing interest, register, and hearing this 7th session of Power Talks. Thank you, everyone, and stay tuned for the next Power Talk session.